This video shows how to find limits of functions using three main methods. So the first method is you're going to use a graph of functions to find limits. The second is you're going to use table of values, which is also called numerical method. The third method is use different techniques such as cancellations or rationalizations, and this is in general is called analytics method. First, let's look at a graph of the function f of x. And we want to find the limit of this function's f of x here using its graph. The questions are, what is the limits of this function when x go to -2, x go to 0, x go to 2, and x go to positive infinity? Okay. At first, look at the functions as x goes to -2 on the left side. The function values go down to the negative infinity. And from the right side, the function values go up to positive infinity. So the function values from both sides doesn't match as x goes to -2. That means the limit of this function when x goes to -2 doesn't exist. Next one, you consider the limits of the functions as x go to 0. And you see from both sides, the function values are approaching to the same point, which is 0. That means the limits of the function should be 0. The next two, when you want to consider the functions when x goes to 2 here, right? From the left side, the function value approaching to 2, and from the right side, the function value approaching to 4, which are different values. That means the limit of the function doesn't exist, and you can look at this graph here is discontinuous. The function is discontinuous when x equals 2. So we can conclude that the limit of the function doesn't exist. Last one, you want to consider the limit of the function f of x here when x goes to positive infinity. And you can see that, look at the graph, as x goes to positive infinity, the function values approaching to 0 but not going to touch 0. Thus, the limit of this function as x goes to infinity should be 0. And you can consider this line here is a horizontal asymptote of this function as x goes to 0. The next method is we're going to use tables of values to find limits of the functions. For an example, you are asked to find the limit of the function sine of x over x when x goes to 0. Numerically, you want to populate a table that includes x, some values of x, and corresponding values of the sine of x over x. So since our interest point is 0, so we put 0 in the middle, and then we pick a few points on the right and a few points on the left that are very close to 0, but it's not 0. Then we're going to compute the corresponding f of x values, function values, to the x values. And then we're going to observe the patterns of these values from the left side and the pattern from the right side. If both sides, the values from both sides approaching to the same number, then we can conclude that the limit of the functions at x equals 0 should be that number. So you can see that from the left side, the function values approaching to 0.999, which is very close to 1. Similarly, from the right side, the function values approaching to 0.999, which is very, very close to 1. So we can see that the limit of this function sine x over x when x goes to 0 should be 1. Now, the last method, analytics. We have two different techniques in analytics, which is the first one is cancellations. Cancellations is when you are asked to compute a limit of the functions as x goes to 0, but then you're having a hard time to find the limits of these functions using direct substitution. Because when you ask yourself, can you plug 0 into x to find the limit? You can't, because 0 will make it undefined here, right, in the denominator, so it's undefined. And the next question is, can you try to eliminate these x values in the denominator so then you can use direct substitution to find the limit? The answer is possible. In fact, you can use factoring. Factoring means in this particular problem, you look at the numerator, you can factor the numerator into x and x plus 1. Right? And then now you have x and x share the same term, so you can cancel them out. And the leftover is x plus 1 over x plus 2. And then you can ask again, can you plug 0 into x to find the limit? The answer is yes, because if you plug 0 into x's, you get 1/2, which is the limit of these functions when x goes to 0. Cancellations, that means you use factoring. And you can use factoring to cancel one of the terms that is a problem. So after the cancellations, you can use a direct substitution, then you can achieve your goal as finding the limit of the functions. And the second technique of analytics is rationalizations. Rationalization is you're gonna use a conjugate term of radical terms. For an example, if you consider finding the limits of these functions, right, and you look at these functions, you have radical terms, and also you cannot plug 4 into x's to find limits because it's gonna be undefined. But then maybe can you try to eliminate x minus 4 in the denominator by using factoring? No, you cannot use factoring. But since you have radical term, then you would think about using its conjugate term. So the conjugate terms of square root of x minus 2 minus square root of 2 is square root of x minus 2 plus square root of 2. If you multiply these two terms together, you will get rid of the radicals, and then the result of this multiplication is just x minus 4. You can see that it's x minus 4, and the same as x minus 4 in the denominator. That will help you eliminate the x minus 4 in the denominator. So here are the steps that help you find limits of this function using the conjugate term. So you multiply the conjugate term to the top and the bottom, and then you simplify the numerator, which is going to give you x minus 4 in the top, and then you can simplify the x minus 4 term in the bottom. And then the next steps again, you ask yourself, after cancellation, can you plug 4 into x's to find the limit? The answer is yes, because after plugging 4 into the x's, you get 1 over 2 square root of 2, which should be the answer for the limit of this function when x goes to 4.